Assalamu alaikum students. Welcome back to the online classes of pharmaceutical quality management. So today again we are going to discuss one of the tests that is applied for the quality control of parenterals. So these are the contents for today's lecture. We will be discussing about the clarity test and its different methods. So these are the objectives of today's lecture. So before moving to the actual clarity test, first of all we are going to discuss what is clarity. So it says clarity is a relative term. It refers to the quality of transparency or purity. Means when any product is transparent or clear, it shows that it is of high quality or it is a pure product that is free from any sort of contamination or any particles. So any undesirable, undissolved particles are not available in the particular product. That shows its high quality or purity. So a clear solution conveys to the observer that the product is of exceptional quality and purity. So whenever your product is very clear, transparent, the observer, the customer may have idea that product is of high quality and purity as it does not contain any sort of the impurities or particles, and its transparency is showing that it's a high quality product, and it shows the hard work of the manufacturer that has been put it into the product to maintain its purity and the quality. So the customer, the observer will be having a positive response toward the product that is clear, transparent, and visibly pure from any sort of the contaminants. So basically this test is carried out to check the particulate matter in the sample. So the sample we have in this chapter is about the parental preparation. So whether we are checking the clarity, means how much product is clear, by checking the presence or absence of any sort of particulate matter in the sample, which helps in the making decision that the product is high quality or purity or not. So as discussed earlier, clarity test is going to be performed by checking the particulate matter in the sample. That's why this test is also known as particulate evaluation test. So means in the test in which we are going to check the clarity or by checking the presence or absence of particulate matter into the sample. So that's why its name suggests as a particulate evaluation test. So we are going to evaluate the number and the size of the various particulate matter available in the sample, and through which we are going to decide about the clarity test of our product. So, what are these particulate matter that are being evaluated in the this test? So, it says the particulate matter refers to the extraneous, mobile, undissolved particles other than gas bubbles and intentionally present in the solution. So, basically, particulate matter term is applied for any particle, any material, any
anything that is basically extraneous, that is not the part of the preparation, that came outside from the environment or through different sources, that has an entry into the parental preparation. So basically they are extraneous in the nature most cases. They are mobile because their size is very small, so they have also the mobility. That's why even through the environment they had an entry into the preparation. And basically they are undissolved particles, so whatever the particles that become dissolved, that we will be unable to check into the preparation. So basically particulate matter are the things, are the particles that remain undissolved into the preparation even after entry into the solution. So they shouldn't be confused with the gas bubbles. So whatever the bubbles that are produced during the mixing, shaking or preparation, so they are these bubbles consumed after this after a short period of time, but these particulate matter remain intact, they remain undissolved over there. So they shouldn't be confused with those bubbles. So basically they are extraneous and undissolved and mobile, so they are basically unintentionally present in the solution or in the sample. So these unintentional presence of such sort of the particles that are either extraneous or they are undissolved one, so they shouldn't be present in the solution, especially when the solution is to be prepared as parenteral preparation that is going to be injected into the vessels. So these matters shouldn't be present. So to check the presence or absence of such type of the material, we need to perform this clarity test or particulate evaluation test.
So the various particulate matter or particles that can be present or that can have the possible entry into the parenteral preparation. These include particles of lint, rubber, insoluble chemicals, and other foreign material. So, uh, the particles that are shaded off through the various equipments or their parts or the garments, protective gears that are being used by the personals working in the area. They can shade the particles in the preparation and that serve as particulate matter as well as some sort of insoluble chemicals. So the insoluble chemicals may be the active or inactive of the same preparation that is being manufactured, but still if the particles remained undissolved after the preparation, they are also referred as particulate matter, and these shouldn't be present in the parental preparation because you can see these produce emboli in the vital organs of animals and the human beings. So these particulate matter have the possibility to make emboli, are going to block the veins and the arteries in the human or in animals. So if these uh, produce emboli in the vital organ of the animals or human beings, that can prove fatal. So therefore, all the parental preparations must be free from such type of the particulate matter that may be foreign matter or that may be even their undissolved uh, active or inactive chemicals. So the product must be free from them to prevent formation of the emboli in the human and the animals. So various methods that are employed for clarity test or particulate evaluation test include visual inspection method, light obscuration method, microscopic count, and video image projection method. So first method is for the checking or observation of uh, visible particles, whereas the remaining three are being used for checking those subvisible particles that cannot be observed or evaluated without help of any equipment or instrument. So these are the basic methods that are applied for checking clarity or particulate matter in the parenteral preparations. So it is practically impossible that every unit of lot is perfectly free from visible particulate matter that are 30 to 40 micrometer or larger in size. Therefore, USP or United States Pharmacopoeia specifies that GMP requires each final container of an injection be subjected individually to a visual inspection, and that containers in which visible particles can be seen should be discarded. So obviously it's impossible that every unit or every vial or every ampule or bottle that is being manufactured for a lot for a batch is perfectly free from visible particulate matter, means the particles that are visible in nature that can be seen by the normal human being, and that have the size of 30 to 40 micrometer or larger. Therefore, the standard specification says that each container, the each vial or the bottle or the ampule that is being manufactured should be subjected to the visual inspection for the presence of these visible or the larger particles in the container. And these standards also specifies that the those few containers or the vials or the units that are having such type of the larger visible particles that should be discarded. So whatever the contents available in those vials or the ampoules or the containers that are having larger visible particles, and their content should be discarded, and that shouldn't be processed for further marketing or other distribution areas. So the first method, visual inspection method, so that involve visual inspection means there is no need of any equipment or extra instrument for checking the particulate matter in the preparation. So as USP says, all containers must be checked. So in this stage, 100% product units from a production line are inspected. Means that each container, each vial ampule from the production line of a batch or a lot is inspected for the presence of particulate matter, especially visible particulate matter, visible particles. How it is performed? So these product units are inspected individually by human inspectors under a good light. So lighting must be proper one so that all the visible particles can be observed by the human inspectors, and that is baffled against reflection into the eye, and that light must be baffled made in a way that it is not reflected into the eye of inspector who is inspecting the product units, and that is how it is the product is checked against a black and a white background. So each component is checked under good light against a black and a white background. So we have black background and we have white background against which we are going to check our product. So why? So it says that the black background is applied for checking or observing white and light color particles. So it means that when the product is having white color or any light color particles, they will be more visible against a black background as compared to white background. So there will be the contrast over there. So when the product is having white or any other light colored particles, they will be clearly visible against a black background. Whereas we have also white background to check any black or any sort of dark color particles. So if your clear solution is having the black color or dark color particles, they will be more visible against a white background as compared to black background. So most simple example I can say you can see when we are discussing in this slide, we are having a dark color background when we are using a white color text, and we are using a light color background when we are using a black or dark color text. So similarly, when the particles are white color or light color, they will be more visible against a dark background, and if the particles are itself are black or dark, they will be more visible against a light or white color, basically the white color background. So by swirling or moving the particle position, so against those backgrounds we have to move our ampule or the vial or the bottle, so that if there is any particle available, that will be more visible after making swirling or moving its position. So if the particles are available are very heavy and they are unable to be visible in simple swirling or moving its position, then you have to invert the container. It means that you have to completely invert your container, so that if the heavy particles are there, they will be easily moving down from the upside to the downside in the sample, and you will be able to observe it very clearly. So in both cases, it is suggested that avoid excessive shaking or moving containers, as it leads to the formation of bubbles which can interfere with the interpretation of results. Means if you are excessively shaking or excessively moving or swirling your containers for checking or for moving your particles, so there are chances that this excessive shaking cause formation of bubbles into the container, which may give you a misleading results that there are certain larger particles are available, but actually they are nothing but the bubbles which ultimately disappear when the movement is removed or withdrawn. So you have to be very careful while performing this test. You are not going to provide extra movements or shaking to the container for particle movement which may create bubbles. So this picture is showing you the test that is being performed on two vials. The inspector is holding them in good light and checking against the white and black background for the presence of the visible particles. So in the industries, the inspectors are checking the vials or the ampoules in this manner for the presence of a visible particulate matter. Second method, we have light obscuration test. It is also termed as single particle optical sensing (SPOS). So it's also one of the preferred method by United States Pharmacopoeia for particulate matter in the parenteral preparations. So as discussed earlier, the these remaining methods uses some sort of instrument or equipment to uh, check the particulate matter in the parenteral preparations. So light obscuration method uses an electronic instrument designed to count and measure the size of particles by means of a shadow cast by the particle as it passes through a high intensity light beam. So the light obscuration method instrument is designed to do both count as well as check the size of the particle uh, by the shadow cast. Means that the particle when it passes through the high intensity light beam, it creates a shadow, and by means of that shadow the particles are counted as well as their size is also measured automatically by this instrument and giving you the particular number and the size of particles available in your preparations. So its detection range is between 10 to 100 micrometer. Means if your preparation is having a 10 micrometer or up to 100 micrometer particles, that can be easily detected as well as they will be counted by this instrument and provide you the result. So this slide is showing you an possible image that the principle that is followed by the light obscuration method, where in the instrument we have light source, we have detector, we have area where the particle can be sensed and detected by the detector, and how the sample is going to be applied through it, and when it passes along with particles, so wherever there is particle, the sensing zone is going to detect it and give a result through the detector, and the particle is detected uh, along with its size, and the results are computed accordingly. Method for particulate matter detection is microscopic counting method. So it is used in case we have an product which is not clear or completely colorless solution, or an viscous product, or an emulsion. So when we are going to dealing with such type of the formulation, microscopic count method is preferred for confirmation of the particulate matter in the preparation. So it says if it exceeds the limits specified for the light obscuration test, it is to be subjected to the microscopic count test. Means if in the light obscuration method, or in the even in the first method, if the limits that are described for the all of the tests they are exceed, they the further confirmation is being done by performing the microscopic count test. So these are the both conditions in which microscopic count method is preferred by the United States Pharmacopoeia for clarity or particulate evaluation in the parenteral preparations. So method or the actual procedure by which this microscopic count is performed. So it says with inside a filter holder fitted with membrane filter with several ml of particle free water. Means first of all you have to take a filter holder with a membrane filter, and you have to make it wet with the help of the water, but that water is free from all type of the particulate matter. So it's a particle free water is being used. Then you have to transfer the sample to the filtration funnel, and then you have to apply the vacuum to filter your product. Whatever the oil or the ampule content you are going to check, so you have to filter it through that filter paper, and you have to apply the vacuum for assistance. Then after filtration you have to place the filter paper, that membrane filter, in a petri dish and allow the filter to air dry. Means you have to make that filter paper dry after filtration, so that whatever the particles are there they can be easily detected through a microscope. So after the filter has been dried, place the petri dish on the stage of microscope. So first of all you have taken the filter paper, you have taken the sample, you have filtered, then you have to dry the filter paper. So once that is dried you have to place that filter paper available in the petri dish on the stage of the microscope for further analysis. And you have to scan the entire membrane filter under the reflected light and count the number of particles. So by using that specific microscope you have to scan the entire filter, so that if there is any sort of particle are there they will be also scanned, and they will be detected by your microscope, and you can also count their number for confirmation. Cells that are being tested while using the light obscuration method or microscope count method include for small volume parenterals, usually 10 units are tested, or sample volume equal to 25 ml. Means if you have ampules or the vials, you have two choices that you are going to check either 10 vials or 10 ampules, or at least their pool volume is equal to the 25 ml for both the tests, for the microscopic count or for your light obscuration test. This is the sample limit for the small volume parenterals. So in case of large volume parenterals or LVP, we have to check at least one or two containers. So one or two containers are taken in case when we are going to deal with the product that is our LVP or large volume parenteral preparation. So the allowed limits for the states as per standard books. So according to the USP or the standards, it says every container should be free from visible particles. That is, the range is 30 to 40 micrometer and larger in the size. Means no any container having visible particles is allowed. So if there is any, you have to discard it. So that cannot be processed further. If there is any single even single visible particle is available in your container, your product, your vial, your ampule. So this is the first condition. Okay, every container should be free from visible particles. Second, for small volume parenterals or we say SVPs, so 25 particles of size 10 micrometer or larger per ml is allowed, and 3 particles of 25 micrometer and larger per ml are allowed. So the allowed limit for small volume parenterals get those subvisible small particles that are not visible without any instrument or microscope, but still there is a limit. Okay, for small volume parenterals, 10 micrometer or larger, they are allowed 25 per ml, and 3 particles of 25 micrometer and larger per ml are allowed. Means it's a 25 micrometer but less than 30 micrometer that are allowed. Okay, so and similarly 10 micrometer or larger but less than 25 micrometer are allowed, include 25 ones. See? So you have to understand this point. Okay, larger is means okay, that is less than the visible or less than the 25 larger micrometer or larger particle are allowed. So for large volume parenterals, 50 particles of 10 micrometer and larger per ml, and 5 particles of 25 micrometer and large per ml are allowed. So if you have 10 micrometer, 12 micrometer size, particles are available or detected through these instrumental methods, then they are allowed for ml are 50, and for uh, larger particles only 5 are allowed per ml. It says if above conditions do not qualify, then reject the sample. So all are the conditions that must be fulfilled. If your product is not fulfilling this criteria, then you have to reject the sample. Uh, or if there is some sort of visible particles, you have to discard your product. So the another method we have is video image projection method that detects moving particles without destroying the product. This is one of the important factors here. Your instrument, your equipment that is being applied for the detection is also not destroying your product and providing you the valuable results. So it's applicable to in-process line detection. It means that during processing, it visual inspection method. So if you are applying any video image projection equipment over there, there won't be any need for the visual inspection method. During processing, during packaging into the final containers, they are being checked by this equipment and confirm the number of the particulate matter in each container. So almost all the 100% product can be subjected to this test like visual inspection, and but further it can be confirmed for the those visible as well as subvisible particles. So this is also one of the important method or equipment for detection of particulate matter during processing. But there's a limitation that it's only applicable for those containers or the product that are having the volume of up to 5 ml. Means only 1 to 5 ml container containing product uh, can be detected by this method. It cannot be applied for those preparations who are having the more volume, or in simple words we can say for large volume parenterals this method cannot be applied, mostly for the small volume parenterals, and even though those are having the volume capacity up to 5 ml. So wherever the instrumental or equipment methods are applied, uh, their disadvantage is the destruction of the sample, like with the exception of video image projection. So any sort of analytical instrument is being applied for the confirmation purpose. So you have to prepare a sample, and there are also more chances of product destruction when the instruments being used for the analysis of sample. So the references for today's lecture include books as well as through the website mentioned. Thank you.